We tend to assume that high-precision measurement, the bedrock of modern science, was born strictly during the European scientific revolution. But long before that, the ancient Indian Rigveda recorded a highly specific observation: sunlight traversing 2,202 yojanas in half a nimisha. If 1 yojana equals 9 miles, and a half nimisha is 0.106 seconds, it translates to over 186,000 miles per second. That ancient figure sits within 0.7% of the exact modern speed of light, 186,282 miles per second. That figure is the direct output of a unified mathematical framework that successfully governed length, weight, time, and the cosmos itself. This logarithmic scale maps the microscopic framework. It begins with the Paramanu, an atom, scaling up exponentially to the Trasarenu, a dust particle, and the Balagra, a human hair tip. Moving into the visible world, it hits the Yava, a barley grain, and finally the Angula. The Angula then stacks into larger human proportions. 12 of them form a vitasti, or handspan, and 24 make a hasta, which is the length of a forearm. The political treatise known as the Arthashastra standardized these lengths for state use. It established an ordinary dinusha of 96 angulas and a slightly longer Garhaspatya dinusha of 108 angulas, explicitly reserved for surveying roads. We have physical evidence of this exact decimal grid. Excavations at Harappan sites yielded shell artifacts marked with perfectly graduated divisions matching these ancient proportions. Those exact same Angula metrics dictated the structural engineering of the Iron Pillar of Delhi, mapping out its precise height and diameter. A single theoretical unit, originally derived from the width of an atom, successfully scaled up to govern the massive architectural grids of monuments like the Taj Mahal thousands of years later. Their mastery of physical space ran parallel to their measurement of time, which also began at the microscopic level with a temporal version of the Paramanu, equal to a fraction of a millisecond. From there, time scales up to human experience. The Nimesa, about 0.2 seconds, grouping into the Kasta and the 48-minute Muhurta. To track a 24-minute unit called the Nadika, the Srimad Bhagavatam details a highly specific physical instrument known as a water clock. This cross-section diagram shows the mechanism: a copper vessel weighing exactly 6 palas, pierced at the base with a golden needle, floats in water until it slowly fills and completely submerges. The exact moment it sinks marks 1 Nadika. This self-validating physical test connected the invisible microunits of time directly to the observable world. The system then expands outward to a staggering cosmic framework, progressing from the Prahara and Dhyana all the way up to the Kalpa, a day of Brahma equivalent to 4.32 billion years. Modern astrophysicists estimate the age of the Earth to be around 4.5 billion years. The ancient Kalpa timeline mirrors that astronomical scale, proving a sophisticated grasp of deep time long before modern geology. The third pillar of this system was mass. The weight hierarchy began with the microscopic Paramanu, scaling up naturally through the Sarsapa, the Yava, and the Masha. Around 2500 BCE, the Harappan civilization engineered exact binary standardization for these weights, creating stone cubes in strict multiples of 1, 2, 4, 8, and 16 to regulate trade. Centuries later, the Arthashastra codified this into a vast state-administered legal metrology, utilizing a network of certified government officers. To manage a diverse economy, the empire deployed entirely separate, dedicated weight series for distinct commodities like gold, diamonds, and agricultural grain. This extended to hyper-precise medical measurements, where traditional Ayurvedic practitioners formulated complex medicines using specific pharmaceutical baseline weights like the rati. By enforcing strict physical consistency, this weight standardization created an economic engine so reliable that Indian goods and measures readily spread across trade networks deep into Persia and Central Asia. This unified metric reality allowed early architects to engineer flawless Harappan infrastructure and enabled astronomers to calculate planetary motion for the Panchanga almanac entirely without telescopes. Long after antiquity, rulers like the Mughals, under revenue minister Todarmal, relied on these exact foundational measures to standardize vast agricultural landholdings across the subcontinent for taxation. The Republic of India formally transitioned to the International SI metric system on October 1, 1958, bringing the nation into the global standard. Yet, despite nationwide metrication, you can still find ancient measurement concepts like the tula for gold and the mana for weight, quietly serving as the functional standard in rural villages today. Ancient India tracked the atom, the breath, and the speed of light millennia before the modern world asked the questions.